Alright, this video is for the Vector Addition Example 1. This will be posted on my website on the Vectors and Scalar page and will serve as a guide for the vector addition problems we'll be working on in class. So the problem is you are standing still near a train track. You see a train going by you traveling east at 20 meters per second. A woman is on the train running at 2 meters per second. What would you measure the woman's speed and velocity to be if she were running A, towards the front of the train, which means east, or B, towards the back of the train, which means west? Now remember, velocity is a vector, speed is a scalar, so these answers will be somewhat similar, but although very different. Remember that a scalar is a measured quantity that has a magnitude or a number part and a unit. And a vector is a measured quantity that has both a magnitude or a number part and a unit, but also a direction. Okay, so you need to have a direction in your answer when you're reporting a velocity or any other vector. So we have a couple methods for adding vector quantities. I'm going to use the arrow method first, and I'll explain that, and then I'll use the numerical method, and I'll explain that. So using the arrow method, first we see that we can represent the train's velocity with an arrow, and we can label it 20 meters per second. We can give ourselves a little key here, and here's east, west, north, and south. So here I've represented the train's velocity with an arrow that's so long. We're supposed to scale them. I'm going to do my best to draw it to scale, but I'm not going to mess around with a ruler right now because, again, this is just an example, and I'm not going to measure the lengths to get the resultant, although if you did perfectly scale them using a ruler or some graph paper or something, then you could, in fact, simply measure the answer later. Now, the rules for vector addition, if I'm using the arrow method, mean that I take the tail of one vector and add it to the tip of the first vector. So I could represent the train here, and to the end of the arrow, if the woman's velocity is first in the same direction east as the train, then I would have a little arrow for her. That's about 1/10 this size because she's moving at 2 meters per second. 2 meters per second. And so then the arrow method says that the resultant, which is what we call the sum of two or more vectors when you add them, goes from the tail of the first all the way to the tip of the second. And then you see that this makes an arrow that is in fact 22 units long, and our units were in meters per second. And it points in the same direction, so east. So I would say for answer A, the woman's resultant velocity, and I can write it like this: V for velocity, or V for velocity or speed, but I put the arrow over it to represent that it's the velocity, the vector version. And I could label it VR for resultant equals 22 meters per second east. I need that label in order to report a vector. If I wanted the speed, V speed is equal to only the magnitude, and I use the absolute value symbol to represent the magnitude of VR, the resultant vector, and then that's just 22 meters per second. For a scalar, you don't need the direction. Now, if I were doing this part numerically, I would simply assign one direction to be positive and then its opposite is negative. In this case, I would probably I'd say east equals plus. And so anything that points east is a positive number. Now, using our proper notation, I could say V1 plus V2 equals VR, 20 meters per second plus 2 meters per second, both positive because both point east, and I've chosen this to be the positive direction. equals VR. And again, that equals 22 meters per second. And since it's positive, right, this plus sign means east. And that's how you interpret the sign of your answer when you're adding vectors using some numerical or a coordinate system where you're choosing a positive and negative direction and stuff. And then you have to assign and interpret the plus or minus signs. That's part A. Now part B, what if she's running west or toward the back of the train? Again, I can use the arrow method first. Here's my vector for the train, 20 meters per second in the easterly direction. Again, I'll draw my little compass rose here, east. Now, she's running 2 meters per second in the opposite direction. So here's where you got to be a little more careful here. The resultant is still an arrow that points from where the first one started all the way to where the second one ends, tail to tip. But now you see that the resultant arrow here is only 18 units long. Okay. So for part B, we would say VR is 18 meters per second. She's still going east. She's going east more slowly. The speed, again, if I wanted just the speed, is equal to the magnitude only of that 18 meters per second. Numerically, again, if I assign east equals plus, then I could say V1 plus V2 equals VR. The resultant is equal to the sum of the first two vectors. Now, I have to be careful and get my minus signs right. 20 meters per second positive for the train plus negative 2 meters per second because she's running west, and that's the opposite direction. So we would say that it is the negative direction, and that is now equal to the resultant. And you see numerically we get 18 meters per second, and since this is plus, again, that means east. And that's how you add vectors. So we'll be practicing in class, and see you next time.